Section 9.7 is the tangent ratio. I can use the tangent ratio to find the lengths of right triangles. A trigonometric ratio is the ratio of the lengths of two sides of a right triangle. One basic trig ratio is tangent, which we abbreviate as tan. I know that you've probably seen this button on your calculator before. There's SIN for sine, COS for cosine, and TAN for tangent. So we're going to use the tangent one here today. The tangent ratio here, so to find the tangent of an acute angle, acute just means less than 90, of a right triangle is the ratio of the length of the side opposite of the angle to the length of the side adjacent to the angle. So if I have a triangle here, and I'm looking for this angle, opposite is over here, and adjacent is here. Adjacent touches, it's right next to, it shares a side with. So here we have the adjacent angle, or the adjacent side, because it's touching our angle here, A. So opposite goes across, doesn't have anything to do with our angle. A is adjacent. Keep in mind though, that it's not our hypotenuse. Our hypotenuse is always opposite our 90-degree angle. So there are two sides that make up angle A. One of them is our adjacent, one of them is our hypotenuse. And then the side that doesn't is our opposite. So tangent is opposite over adjacent. We're going to deal with sine and cosine in section 9.8, but we're going to use SOHCAHTOA to remember this. SOHCAHTOA. And we're not going to worry about SO and CA. We'll get into those tomorrow, but for today, we're going to deal with TOA. And TOA comes from the fact that tangent equals opposite divided by adjacent. TOA. Opposite over adjacent. So if we look at triangle PQR on page 486, we can find the tangent of angle P. So again, if we look at page 489 here, I drew in the picture here kind of that's in the book. We're looking for a tangent of angle P. So we look at angle P. And from here we label our opposite, adjacent, and hypotenuse. So opposite goes across from our angle. Adjacent shares a side with our 90 degrees and the angle that we're looking for. And our hypotenuse is our other side, the one that shares with our angle but not with the 90 degrees. It's opposite of our 90 degrees. So opposite of P, adjacent to P, and our hypotenuse. Remember, when we're looking for tangent of P, I'm going to write tan of P equals, we take opposite over adjacent, TOA. Opposite is 77, and adjacent 36. So tangent of P, we leave at 77 over 36. Now, feel free to pause here and give this a try if you'd like. For triangle PQR, from example 1, so the one I have drawn up here, we're going to find tangent of Q. Now, we're going to select angle Q. And from there, we need to determine our opposite, adjacent, and hypotenuse. They're not always the same, guys. If we have different angles, we have different things adjacent, different things opposite. One thing that always stays the same, though, is our hypotenuse. So our hypotenuse is still going to be the 85. Okay, it's still going to be our longest leg, our longest side, the side opposite of our 90-degree angle. Adjacent, though, is the one between our angle we're looking for and our 90 degrees. It's the one that touches our angle. A for angle, adjacent. Opposite is the one across. So here, 36 is our opposite. So for angle Q, when we find our tangent here, remember we still want opposite over adjacent, TOA. Tangent equals opposite over adjacent. Our opposite now is 36. And our adjacent, 77. So tangent of Q equals 36 over 77. We can also use a calculator or a table of trig ratios to find our trig values of specific angles. The trig ratios are on page 823 in your textbook, but it's also fairly easy to do on a calculator, so that's the way that I'm going to go here. If you look on page 823, you'll scroll down to find the angle number you're looking for. So for example, we'd go down to 18, and then we'd go over to the tangent column, and there would give us our 4 decimal place answer for what tangent of 18 degrees is. But here I'm going to do it on a calculator. So if you have a 2-line TI like we do up on the poster in our room, first thing we want to do is make sure that it says DEG. If you have a Casio, sometimes they just have a D. Make sure it's in degrees. Okay, so make sure that's selected. If not, like on the 2-line TI, next to the second key, there's a DRG. Select that, and then make sure DEG for degree is highlighted. Press enter. Now, once DEG is on your screen, you're just going to type in tan. It's going to pull up a parenthesis with that tangent. Okay, so press your tangent button, TAN. You're going to put in 18, close your parenthesis, and press enter. And we're going to get 0.324919696. We round trig ratios to 4 decimal places. So we look here, 1, 2, 3, 4. The number after it is a 1. 1 rounds down, so we're going to keep it at 0.3249. And if you use the table on page 823, you would have gotten to the same value. We just won't have that available all the time. Same idea here with tangent of 45. Again, if you look at page 823, you can go to 45 degrees. So go down the column with the degrees in it over to tangent, and it'll give you your value. If we type it in our calculator here, tangent 45, enter, gives me 1. And that's because in 45 degrees, this is a really bad drawing, but pretend these are both 45 degrees. If I have the same angles, guys, I'm going to have the same side length. And we find the ratio of our side lengths. So opposite over adjacent. Anything divided by itself is always 1. So whether these are 80 and 80 or 0.80, 0.80, doesn't matter. We're always still going to take something divided by itself, so we get 1. So tangent of 45 degrees is 1. Now, feel free to pause here and give this a try. Tangent of 10 degrees. So again, we can either use the chart in the back of the book or tangent of 10. We're going to get 0.176326981. And we round it to 4 decimal places. So I go 1, 2, 3, 4. I look at the 2. 2 is smaller than 5, so it rounds down. So here we get 0.1763. And that equals tangent of 10 degrees. And we're going to use an approximate here because it's an approximate value. We round it. Tangent of 75 degrees, again, we're going to type in the tangent key, TAN. It's going to pull up a parenthesis. We'll put 75 in there, close our parenthesis, press equals. So tangent of 75, my calculator gives me 3.732050808. 4 decimal places, 1, 2, 3, 4. I look after. 5 rounds it up. So I'm going to have 3.7321. And that's going to be my tan of 75 degrees. Tangent of 75. Ooh. And there you go. In example 3 here, we're using a tangent ratio. When the sun's rays strike the moon's surface at an angle of 6 degrees, the edge of a lunar crater creates a shadow that is a length of about 4,700 meters. What is the depth, d, in meters, of the crater to the nearest 10 meters? So here, the picture, there's one in the book on page 490, but it looks kind of like this. So here's our triangle. It's telling us that this is 6 degrees, and that the shadow length is 4,700 meters. And we want to know, what is the depth of the crater? So here, if we label our sides from the angle we're given, I have my hypotenuse opposite my 90 degree. From my angle to my 90, so my angle side towards my 90 is my adjacent, and opposite of my 6 degrees is my opposite. So the values I have here are A and D. So we're going to use tangent, O and A. Tangent of my angle measure of 6 degrees equals opposite over adjacent. And opposite here is D, and adjacent is 4,700. So tangent of 6 degrees equals D over 4,700. Now I need to solve here to get D by itself. It's being divided, and we get rid of division by multiplying. So I multiply whatever I do to one side on both, multiply by 4,700. And here I get 4,700 times tangent of 6 degrees to be my depth. We can go ahead and type that in our calculator. Just like I have written, 4,700 times tangent 6 close. Because it'll give you a parenthesis with your tangent. Here I get 493.9899057 meters. But we went around to the nearest 10 meters. So we went around to the nearest 10th spot, right here. I look at the 3 rounds down. So instead of being at 493, I round down to just 490 meters. And that's my approximate depth. And that's all I have for section 9.7.